Today we're learning about galvanic cells, and you actually built one of these in your lab already, and this is the whole basis behind how a battery operates. So today what we're going to do is, given a redox reaction, we're going to figure out how to set up what that would look like if this reaction were run in a galvanic cell. And of course, the whole purpose of a galvanic cell is to be able to harness that electricity to be able to do something with it as those electrons are being transferred. So I'm going to take you step by step in how to draw one of these galvanic cells. The reaction that we're going to be analyzing is a copper 2+ ion reacted with zinc will yield a copper ion, or I'm sorry, a copper metal plus a zinc 2+ ion. And I really probably should have put the phases in here. Ions are going to be in solution. These metals are going to be solids, and so this ion will also be in solution, so it will be aqueous. Okay, now it's good to have a pattern so that every time you draw a galvanic cell, you don't end up confusing yourself by accident. So whenever I draw a galvanic cell, I always start by drawing two containers, and I have just decided that whenever I draw one, I want my anode, which is the negative terminal, to be on the left-hand side, and I want my cathode, which is my positive terminal, to be on the right-hand side. So if I look at this reaction up here, I know that the zinc and the copper are both going to have oxidation states of 0. So if my copper is going from a +2 to a 0, the charge has gone down. It's had to gain electrons in order to do that, and so that meant that the copper is what is reduced. The zinc, which went from a 0 to a +2, is what was oxidized in this particular reaction. Now, another thing that you can use just to help you kind of keep things straight is, if you remember the phrase red cat, and so I could actually draw a red cat over here. Okay. Not a very good cat, but you can get the idea. And I think of red cat to remind myself that reduction always occurs at the cathode. So whatever happens, this reduction is going to happen over here at the cathode. So in this solution, with my anode on the left and my cathode on the right, I know that I have to have an electrode in each one of these. And additionally, I have to have a wire connecting those two electrodes. The electrons are always going to flow from the anode to the cathode. They can't go any other way. They have to go that direction. Additionally, a galvanic cell also has to have a salt bridge in between the two halves of it, because eventually what happens is you get so much negative charge built up on one side and so much positive charge built up on the other side that the reaction cannot continue to run. So the salt bridge that you put in the middle is able to put positive and negative ions into the solution on each side, so that it will kind of neutralize things out as far as positive and negative charge, and the reaction is able to continue. Now, both of these sides are going to be aqueous solutions, so they're both going to be filled with water. So I'm going to put my water level in there. Okay, red cat says that reduction happens at the cathode. So what is being reduced is the copper is going to a solid copper. So what that means in here is that in solution, that's where my copper ions are going to be, and that's where the copper is going to come out, and it's probably going to be collecting on this electrode over here. This electrode is going to be made out of some other type of metal. It doesn't make a whole lot of difference right now to you what this other metal is. If you take an advanced chemistry class, if you take it in college, you'll learn how to determine what that particular what metal that particular electrode might be made out of. Okay, the anode then is where the oxidation is going to occur, so that means the solid zinc is what this electrode is made out of, because it's on the reactant side, so you know it had to start out at this. So this is a zinc electrode, and therefore that zinc electrode is going to start to lose electrons. This solid zinc is going to, as it loses its electrons and they start to flow over here, there's then going to be zinc ions in solution over on this side. Okay, so this is basically how you're going to put together a galvanic cell. First thing you need to do, just to kind of sum things up here, you need to decide which element's being oxidized, which one's being reduced. Okay, then you're going to put electrodes on each side. You're going to put a salt bridge between the two of them. Remember that there's aqueous solution on both sides, so it's going to be a liquid. Electrons always flow from the anode to the cathode. And just for simplicity, I like to put my anode on the left and my cathode on the right, so that electrons are always flowing the same direction, so I don't confuse myself. Red cat will help you remember that reduction happens at the cathode. So then you're going to look at your reaction and say, okay, which element was reduced? The copper was reduced, and so that's going to be what's on this side. And because the oxidation happens at the anode, the zinc is what has to go on this side. The reactant is what the electrode has to be made out of. So since you've got zinc solid on this side, what that tells you is that the electrode has to be made out of zinc on this side as well. You're going to get lots of practice today drawing different kinds of galvanic cells, practicing which side goes on the anode, which reaction goes with the cathode. So as you work through that, make sure you're checking your answers carefully so that you don't learn anything backwards. This particular reaction is one that is often used to make a lemon battery. And so if you check out the other link that I sent you for today, you'll be able to see this reaction happen inside of a lemon.